Hey, this is Mark, and today I have an iPhone 7 Plus that somebody has made a real mess of. So I'm not even going to try and guess why this person did what they have done. I'm just going to say, I'm very disappointed in you, sir, whoever you are, that did this to this poor phone. So we're going to start trying to kind of uncover some of the damage here. We got a random resistor that was just floating around over here. Maybe we'll figure out where he goes. Maybe not. Who knows? We're just gonna pick away a lot of this waterproofing. It's not really underfill. It's a black goop, but I don't think it doesn't qualify as underfill. It's a lot softer, and it seems to be that the purpose of it is just waterproofing. It's not really like a like underfill is more to like secure chips down and kind of glue them to the board. This stuff is more like just keeps water off these little components. So we're just going to pick a bunch of this away, get it out of the way, and really get a good look at what we're working with here. Oh, you poor, poor iPhone. You have been abused. Just shameful. This is just shameful. If you ever find yourself in a situation where your board is starting to look like this, you should maybe just stop what you're doing and say, hey, I'm in a little over my head. I should probably quit right now. And if you do get a board into this kind of shape that we see here, where we have pulled pads on a connector and lots of little missing components around it, I strongly suggest that you send that board that you are obviously not capable of fixing. I strongly suggest that you send that to Louis Rossmann and request that he fix it personally on stream. I know he will be happy to oblige you. Definitely do not send it to iPad Rehab. All right, so I just kind of wanted to get all of this waterproofing stuff away and out of here and see if there's any other kind of loose guys that weren't obvious at the beginning. Oh good, we got another loose resistor. See, that's exactly perfect example of why I'm doing this. Another loose resistor that I had no idea was even there. Like most of these components, I don't have any idea what these guys are, because there's never going to be a situation where they need to be replaced, right? Because nobody would ever do something like this. Nobody would ever do that. Like, who's gonna knock these two guys off and then also knock all of these guys off, and this guy, and that guy over there. Like, nobody would ever do that. It's just insane. Nobody would have that little regard for their customer's device. All right. See, these guys are a little loose. Like, I'm picking this stuff away, and these little dudes should not be moving this easily. I'm barely touching them, and they're getting a little wobbly. Okay, so we've got a resistor up here that looks like it probably goes up here. And then we've got 4 guys here. I don't know what they are, and they're completely gone. Got a couple of guys here that need to be resoldered. This guy was a no stuff, so he was never a component to begin with. This little resistor, he seems okay. All of these guys seem okay. I'm not sure what these 2 guys right here are. Definitely we're going to need a jumper right there. And actually, I think this might be one of the backlight anode lines. Then we got a missing pad here that goes to one of the LCD image data and clock chokes. So we're definitely going to need a jumper there. And then we got a missing guy right here, which I suspect is this resistor. Don't know, but I think that's what we're going to find. So let's jump over to TXW and see what we have here. All right, so this guy is a resistor here, so he probably goes there. Then let's see, what was our other guy? We got 1, 2, 3, 4, 5. One, 2, 3, 4, 5 is a cap, so we can probably ignore him. So where is that random resistor from? Could be one of this row that's missing over here. Let's see. What are we missing on that other side? Got big guy, then 1, 2, 3, and then we're missing 4, 5, 6, and 7. A big guy, then 1, 2, 3, and we're missing 4, 5, 6, and 7. So number 5 is 200 ohm resistor, and number 6 is 150 ohm filter. So we're okay ignoring these caps. All right, let's see. Let's see what the value of this loose resistor is. Are you 200 ohms? Holding on to them long enough for it to take the measurement is going to be the hard part. Yep, that's 200 ohms. So that guy is going to go right here. And then we need a filter, which actually an iPhone SE gas gauge filter should be a good match for that spot. So let's go ahead and knock that out. We'll stick this guy up on top, back in his spot, and he's kind of, the bottom has been torn off. So what I can do is just put him on upside down, and that way the ends and the top side of him will make a good connection to those pads. Now if I need to, I'll find a good replacement, but usually you can kind of get away with this. I think it'll be fine. All right, we're going to get this guy down here. All right, he's in place now. Dig up the old iPhone SE/5S gas gauge filter. And what have I done with him? Oh, there we go. All right, little guy, you're going to go right over here. Now, all I'm doing right now is kind of, see fucked up, replace fucked up. So I do need to kind of take note of what function all of these components are related to, so that I can make sure that I properly test that functionality once the repair is done. All right, so last thing I need to check is what is this guy? He's a cap. And this big guy, he's a cap. This little guy, he might also be a cap. Let's see if I can just read the board and avoid having to look him up. Let's see. Okay. The big one over here is not a cap. The little one is a cap. So the big one, I think, is going to end up being a backlight filter. Let's see. Backlight anode is my guess. A backlight cathode. All right. Okay. I can work with that. Where are my backlight filters? Now, the big question here, oh man, the big question here is when you see this kind of fuckery, this kind of just pointless just brutal damage, you have to wonder why, right? I mean, that's kind of the thing we should be thinking about every repair is, how did it become like this? How did it come to be this way? Why? Why did this happen? Right? And when I see this kind of brutality going on in the LCD connector area, it makes me think that back before all of this damage happened, there must have been some problem with image. So, you know, it's entirely possible that I'm going to fix all the damage that this tech caused, and that I'm still going to have to track down and solve some, you know, root cause of an image problem that this tech was trying to fix when he made, you know, the series of poor decisions that led to the phone being in this state. So, you know, it's pretty likely that, yeah, it's definitely ground there. Pretty likely that once I get this connector back on, and, you know, now that I have all these components replaced, that there's still going to be an image problem I have to fix. Maybe not, but, you know, pretty likely. All right, so I'm not going to switch the view over. Oh, crap. I've been on ZXW this whole time. Sorry about that. Yeah, so I just put a filter back on over here. That's all I've done. So I've got resistor back in place, filter in place here, filter in place here. That's a cap, that's a cap, that's a cap, or that's a no stuff. That's a cap. So I can ignore those, and then resistor back in place here, placed upside down. Now I'm going to put the connector back on, and I'm going to know that there's probably a good chance that I'll still get no image and have to actually troubleshoot what the root cause of the problem was. All right, so let's prep for this connector. And all of you guys out there that continue to watch my videos, I really appreciate you guys. I know I'm kind of sporadic in this, and I do things like leaving it on ZXW while I'm working so that you can just listen to me talk rather than actually see what I'm doing. So I appreciate the fact that you keep coming back, even though the quality could maybe be a little better. It's not going to be, but I acknowledge that it could. And I appreciate you, each and every subscriber. All right. So we got that prepped. We'll zoom out a bit. And ooh, that's not gonna work. All right, I'm gonna have to knock this down a bit. This ground that the nameless tech who raped this board has exposed. Gonna knock that ground down a little bit so that it doesn't keep my connector sitting too high. All right, that'll work. All right, let's see if we can get in here with some hot air and get this sucker on. Ooh, not so good. So, what went wrong there? Why did that plastic melt that quickly? Give you a second to think about it. Come up with your answer. Okay, time's up. The reason why that plastic on the connector melted so quickly is because that connector was still sitting raised up too high, right? Because these ground pads have a lot of solder on them, so they were keeping that connector raised up really high, and in doing so, that keeps the heat from transferring out of the connector and into ground like it should. Like, when the connector is flat against the board like it really should be, a lot of the heat that you deliver into that connector gets transferred into the board. So it can tolerate a lot more heat than it can when it's raised up above the board. So we're going to give this another try. With those ground pads, those anchors at the ends kind of knocked down a bit more. All right, so yeah, now the connector is actually down on the board enough that I can solder pins to their pads. Whereas before it was sitting too high and all I could really get connected was the ground, the anchor points at the ends. Now I can actually get pins on pads a little better. So this time around, it should go a little more smoothly. And look, I know somebody out there is gonna be like, "Oh, you should totally take that board out of the housing." You're gonna come say that in the comments, and I'm gonna ignore you. But I'll go ahead and address that now. Uh, it's fine. It's not a big deal. The phone can be in the housing for this job. It's not the end of the world. Trust me, bro. Now look, same exact temperature. I haven't adjusted my hot air at all, but now I'm not melting the connector, and I am melting the solder underneath the connector. So before, that connector melted before the solder even started to melt. Much different this time around. All right. Now I'm going to go down these connector pins one by one, just kind of give them a little touch up, a little kiss of solder. All right. Just do a little bit of cleanup here. Like, yeah, sure, our speaker got a little bit melty. Sure, but that's just the housing. It's going to have absolutely zero effect on the finished product. The only person who's ever going to know that that housing got a little bit melty is technicians who work on the phone. And I trust that my secret is safe with them. Oh, and also everybody who watches this YouTube video, but I trust that all 150 of you guys are not going to tell anybody that I melted a speaker once on an iPhone 7 Plus. It's just between us. Shh. All right. So flux is cleaned up good enough. Now we need to do our couple of little jumpers. So, oh, also, I didn't point this out yet, but we also have this right here, which I'm just going to pretend I didn't see, and we're going to just cross our fingers and hope for the best that this long screw damage is not actually a problem. I'm sure it's fine. It's probably fine. Just don't worry about it, all right? Just don't worry about it. All right, let's get some of this here jumper wire. And that's enough. Okay. We're gonna, you know what, I don't have to expose any copper there because I can just solder right to that pad. And don't have to expose copper there because I can solder to that pad. So good to go on both accounts. We'll do this side first. Gonna just tin up this wire real good. Get a nice chunk of solder on there. And get it right up under that pin. There we go. Now it's nice and connected to that pin. Yeah. Yeah, that's good. When I poke the wire, it wiggles the pin inside of the connector. That tells me I have a nice solid connection there. So now I'll flip it around and we're going to do the same thing over here. Plenty of flux. There we go. There we go. You see that wire's nice and soldered onto that pin. Ah. All right. Still connected to the pin good. So now Now we are ready to see, is there some other fundamental problem that existed from the very beginning before any of this fuckery started? All right, let's get our old iPhone 7 Plus tester LCD out. And we will power off DC power supply because this battery is almost certainly dead. Okay. Holy crap, we have image. Oh my god, I did not expect that. That's amazing. That is amazing. Are we going to have touch? There's no way. No way we're going to have touch. It has to have had some major problem for it to ever get like that. Like, what kind of... Oh, so glad it's not here for data. All right, there we go. We have working touch. And obviously, we're not going to get data off of this phone because it says that it's been disabled. But you know, with a wipe, with a restore, this phone's going to work just fine. So there we have it. I'm not going to spend the time doing it right now, but just know that I will go back and check all of the lines that had components knocked off of them, just to make sure if they're related to anything besides image and touch. Then I'm going to wipe the phone and get through the activation and test that. So, you know, not really worth doing on video. Our main problem was that it had no image, obviously, because it had no LCD connector. Now it has image. So we're good to go there, and I'm going to call this one done. Thanks for watching.